Good morning, friends. Today we'll cover chapter 20, which is Singleton pattern and read-resolve method. So, in software engineering, the Singleton pattern is a software design pattern that restricts the instantiation of a class to a singular instance. The pattern is useful when exactly one object is needed to coordinate actions across a system. Or more specifically, we can say that the Singleton pattern allows objects to ensure they only have one instance throughout the one JVM process. There's only one instance available for that particular Java project or Java class, and provides easy access to that instance and control their instantiation by hiding the constructors of a class. So this is what a Singleton pattern is. If we want to look at the example, so here I have got this Java Pojo class, which is marked as market data singleton, and it has got some private member fields and the reference field as well. And suppose I want to make it singleton, the very naive way to do is that first of all I mark the constructor as private, so that the object cannot be created by just providing a new operator, because the default constructor is private, so new operator will not work. And then when the class is loaded here by the class loader, in that case I can create this object using the new operator here and refer it and give a reference object, something as instance to it, and mark it as private static final. By marking it as static, it means that it would be this new operator would be created, or this object would be created when the at the start of the JVM process. And to get this one only singular instance here, we provide a public getter method, which will return this instance. So by having this pattern, it ensures that first of all that object cannot be created by new operator outside of this class by the client, and when the class is loaded, at that time only this instance is created with using the new operator. And we are also providing the static static getters to get this instance object, this singleton object for it. But what happens if I implement serializable here? Will it still be a singleton? Will it still be written only like one instance when it is serialized or deserialized? This is what we're going to cover in this chapter. So previously we have seen that we have got this read-resolve method, right? And we know that deserialization process will always contain the copy of the original object. Thus, it will break the singleton design pattern as only one and same instance has to be there in a current JVM run. So if I look at his design again, so once we serialize this object, and so it will create a stream of bytes, and in most of the cases we are writing it to a file, right? And then we deserialize it by using object input stream dot read object method. And once you get the stream of bytes here and construct the object here again, this object is not the same object as it was serialized here. It's actually a copy of the original object. So in case of singleton now, because we have to maintain the same singleton instance, and once we deserialize it back, we are getting a copy of the original object. So it's not the same instance as it was serialized. So it will break the singleton pattern here. Or in other words, any class would no longer be a singleton if it implements serializable interface. It doesn't matter. We have learned a lot of techniques, like we can override the default serialization process by providing read object or write object, or marking it as whitelist field and all. But it doesn't matter, because whether the class uses a default serialized form or a custom serialized form, nor does it matter whether the class provides an explicit read object method. Any read object method, whether explicit or default, returns a newly created instance, which is a copy of the original instance. And it will not be the same instance that was created at class initialization time. Because in our Java Pojo, this our singleton Pojo class, we are actually creating it at the start of the JVM process, where we are assigning it here using a new operator. So this is not the same instance when we deserialize it back, because it's always the copy of this instance, not the same object. To solve this issue, now we have got this read-resolve method that we learned in the last chapter. So the readResolve method allows to substitute another instance for the one created by read object. Read object will create a copy, but readResolve, we can actually create any type of object and return it back. And that would be actually the deserialized object once after calling this readResolve method. If the class of an object being deserialized defines a readResolve method with the proper declaration, I mean the signature is very important. This method is invoked on the newly created object after it is deserialized. And the object reference returned by this method is then written in place of the newly created object. Because the copy that we got from the read object, the copy of the original object, there's no reference to the newly created object is retained. So it immediately becomes eligible for garbage collection. So let's go for the example here that we have created. So here we have provided this read object method. And once we call this default read object, so it will give me the copy of the original singleton instance, not the same instance. But we have also defined this readResolve method here, which means that in here, whatever is returned, so here in this case, we are returning the same instance which was created when this object was serialized. It's not the copy of this original object. So here we are overriding this default behavior by providing this readResolve method and returning the same instance as it was created at the class initialization time, and that will be returned. In that case, we actually we still have the singleton reference even after the deserialization process. So guys, let's jump into IntelliJ and write some unit test case to understand it better.